You can start wherever you want, man.
Okay, you know what? We'll just go where you want. Can we do just review number 3, I guess? Like one of the pound from 1 through 4. Just do number 3 again.
Sure.
It's kind of been a while.
Sure. All right. So here, we're told that our parent function is x squared. So any transformation of that is going to look like this. So my first step is going to be to rearrange my existing equation so that I can easily pick out my values for A, H, and K. So the place where I really have to be concerned is this part inside the parentheses. It needs to look like this. So I would start by factoring out that -2. Okay with that? From there, I can get that the A is 1, the C is -1/2, the H is 2, and the K is 1. Again, A is 1, C is -1/2, H is 2, and K is, -1, excuse me. Leo?
Can you explain the H part? Just like what the correlation is? Like, so why is it positive while it's negative up there?
So if you look at the original equation here that we're working from, it's a minus h. It's x minus h. Okay. So if I plug in a value of +2 for h, I'd have x minus 2. Right, so the h is going to be always the opposite sign that it looks once you've got it in that factored form.
Okay, that makes sense.
And the c is always going to be the reciprocal of what you've got it in that factored form. Is that okay?
Yeah.
Okay. Now from here, we would want to just, I think it also asks us to describe what's going on. So since that c is negative, we're going to have a reflection across the y-axis. And because the absolute value of c is less than 1, we're going to have a horizontal shrink by a factor of 1/2. The a is positive and the magnitude of a is 1, so that doesn't do anything. Cool with that? I'm just not going to write anything down for that. Is that okay? Okay. Since the h is positive, we know we're going to go right that many units. And since the k is negative, we're going to go down that many units. So that's the gist of it there. Is that okay?
Yeah.
And again, I think on worksheet 1, the first page has those criteria I typed them all out for you nice and neat. So
You gave it to us.
in addition to giving them in your notes or whatever, I put them on this worksheet again because you had to use it a couple of places. So.
Oh, one more thing.
Sure.
It's just a general question. So, like number 4, the one like right after it, is it already in the regular form, or do we have to? Can we factor that more, right?
Yeah, you'd have to make sure that you factor the inside part there.
So it's just like x minus 1. Okay, cool. All right.
So the a is -2, the c is 1/2, the h is 1, and the k is 4. And then you can go from there.
Yeah.
That's usually the hardest part, is making sure you get the right values for A, C, H, and K. If you goof that up, then obviously the next parts are going to get goofed.
Yep.
Sure. Who's next?
I have a question on worksheet 2.
Yeah, let's do it. Worksheet 2?
Can we go over either number 5 or 6? Those are a little confusing for me. I
Sure,
don't know what to do.
sure. Oh, okay. All right, so what I'm going to do is I'm going to first start by identifying the values for A, C, H, and K. So in this problem, A is -1. We good there?
Yeah.
C is 2. H is 0. And K is 1. I'm going to use that to build my function map. So that function map is Cx plus H, Ay plus K. And I'm going to use that transformation map on my key points for x squared, which I think I gave to you, and probably I wrote them on the other worksheet. But these are the 5 key points for x squared. I think I put them on the other worksheet, but same key points because that's the same parent function. And I'm just going to kind of plug things in. So I'm just taking my -2 and plugging that in for x. So 2 times -2 is -4, and then plus 0 is still -4. And I'm taking the y and plugging that in for y. -1 times 4 is -4, and plus 1 is -3. And I'm just going to kind of continue doing that. Oops. Oh my goodness, that's a 0 there. Great googly moogly. And then what's that? 4, -3 again. So then I'd plot these things. So like 1, 2, 3, 4, -3, -2, 0, 0, 1, 2, 0, and then 4, -3. So when it says like make sure you show your work to find the reference points, like this is what we're talking about. Yeah, it's showing the function map you used and then how you transform the key points to the new ones.
So for the x and y values, are those universal? Like we use those for every single problem like this?
So these x values here are when the parent function is y equals x squared.
Isn't there like another one was like 3? And
so if you look here, again, it's an x squared problem. This was an x squared problem. If you went to worksheet 1, the graphing problems were x squared problems. So I think for this homework assignment, those were the key, for homeworks or worksheets 1 and 2, those were the key points.
For number 11. Number 11 and 12, I think.
On worksheet 2?
Yeah, is that one we had to use different? Because there's not.
Oh, sure, yeah.
That's when we used, I forget what the point.
So for worksheet, or for 11 and 12 here, the key points you'd use are the ones on the graph.
Right, okay, cool. Yep.
So you just use those 5, the ones that are given to you in the problem.
Okay.
So those would be your key points from the parent function.
Yeah. That's right. All right, beautiful, thank you.
Yeah, no problem. Leo, hand or stretch?
Just a stretch.
Okay. You keep on stretching then.
Yeah.
Who else? Do you want to talk about some more of these?
Yes.
Yes.
On
Keep.
worksheet 3,
Sure.
on like 7 or 8.
7 or 8. Sure.
How are we supposed to find the y values for these?
Okay. So 7 or 8 are just the fundamental values for sine or cosine. So like literally we're just using the key points that I gave you in the notes. So there's no calculation to do, you're just using, those are the points you're using.
Okay.
So you're just plotting them and then like extending. So for example, if we're doing let me grab one of those. Oops. For sine, the key points were 0, 0. These I have memorized, but they were on that list that I just showed you a moment ago, so I'm just going to say them aloud. Pi over 2 and 1, pi 0, 3 pi over 2 negative 1, 2 pi 0. So like that much we have, right? And there's still the directions ask you to like fill the blanks. Oh no. Oh, graph the curve on the given axis. All right. But we should kind of extend this to fill the space. So like if I extend this from this direction, let's see, the next thing I would do is I'm starting over. So I'm like going from here to here. So the next spot should be like there. And then going from there, I go back down to there. And then from there, I'm going down to there. And then once I'm there, I go back up. So then like I have another period. And I should do the same thing in the other direction. Is that okay?
Yeah.
So that's all I'm doing to graph those two. Is just I'm using the points that I gave you. On 9 through whatever 14 or something is the next grouping of problems. Or 15 or whatever, you'd be using those, you'd be transforming those key points.
Okay.
Using that transformation map we just showed you.
What about the top ones, like the
Oh, okay. Sure. Those would have just come from our table.
Okay. And so here I was asking, like, how do I get the y value? So which is midline?
Yeah, so it's just y equals 0 for sine. Right?
So is it always y equals 0?
For sine, without a transformation, yes. If sine has undergone a transformation, not necessarily. So those values I just copied out of the table as well. Is that okay?
Yeah,
Do you want to do one where we're doing a transformation?
I guess so.
Okay. So let's, do you have a preference?
No, anyone's done.
Okay. Let's just do 9 then. Sound good to you?
No.
Okay. All right. So I would start by trying to rewrite this in as a standard transformation. So I want to do a little bit of factoring to get it in this form so I can pick out the values for A, C, H, and K. Good with that? Just like we had done before. So the place I have to worry about is factoring this inside. So I factor out that 2, and when I factor a 2 out of the pi, that becomes pi over 2. Is that okay?
Yes.
So when you're factoring the things out, you're dividing, right?
Yeah.
So that's how I end up with pi divided by 2, or just pi over 2. No?
No, I'm just confused on where the pi came from, though.
Oh, it's right here.
Oh, I didn't
Right.
see that. Okay. So all I saw. Oh. Okay, I see.
So I'm just factoring the 2 out, right? You're good?
Yeah.
Okay. So here my A is 1, my C is 1/2, my H is pi over 2, and my K is 1. Now if I go and I look at my table here for my transformation, my amplitude is the absolute value of A, my midline is y equals K, my period is 2 pi times the absolute value of C, and my frequency is the reciprocal of that. So here, my amplitude is just the absolute value of 1, so 1. Here, my midline is y equals K, so y equals 1. Here, my period is 2 pi times 1 over 2, which is just going to be pi. And my frequency is the reciprocal of that, so 1 over pi. So far, so good?
Yeah.
Okay. Now I'm going to write my transformation map. So it's C times X plus H, and then A times Y plus K. And I'm going to go back to those key points from my notes. So we're doing a sine function, so we're using these key points. Right? I know it's a sine function because it says so in the problem, right? Okay, so this one just becomes pi over 2, comma 1. This will become a quarter pi plus a half pi becomes 3/4 pi. And then 2. And then there's a half plus a half will be 1 pi still. And then that'll be 3/4 plus a half would be 5/4. Oops, 0. And then that would be 1 plus a half, so that'd be 3 over 2. 1. Is that okay?
Yeah. How do you know when these are going to be like a transform?
Well, because it's got like stuff in there. It's just not like y equals sine x.
Oh, okay, I see.
So if it's got any values for like, if A is anything other than 1, or if C is anything other than 1, or H is anything other than 0, or K is anything other than 0, then it's a transformation. Like if there's any numbers in there at all, got to do something. Does that make sense?
Yeah.
Okay. So then we'll just plot these bad boys. So pi over 2 and 1. 3 pi over 4 is going to be like halfway here, and 2. Pi 1 is there. 5 pi over 4 and 0 is there. 3 pi over 2 and 0 is there. So like I have this much. And then I should fill up the rest of my space. So I'm just going to kind of continue the pattern from here. So just up there, back to the middle, to the bottom, middle, top, middle, bottom, middle, top, middle. And then again, extending it backwards as well. Bottom, middle, top, middle. Is that okay? So again, computation-wise, like it's not too bad, right? We just have a bunch of little equations or whatever that we're using to find these values that all boil down to like, can I get the correct values for A, C, H, and K? Because those are the things that I need to plug into my little formulas. Is that,
Yeah.
you know, it's something, right? What do you think? We can do more if you still got more to talk about. I know it's been a little while since we've talked about this stuff, and I've asked you to do some other stuff even past this in the interim, right? So we have a lot of things to ask questions about that are on the table for anyways, right? Because this problem set that we're coming up on is turning into a pretty big beefy boy.
Homework 3 due? Sunday?
No. No. But it had been assigned.
Yeah.
We hadn't had a chance to talk about it yet, which is why it wasn't in the Sunday's problem set. But it's going to be in this Sunday's problem set, so certainly good idea to, if you're not sure what to do, to get things clarified so we can, you know, finish that without a whole lot of headache. John or Joe?
So like I understand how you get the A, M, P, and F values and all those kind of things. But for the X and Y values, when you're trying to find the like the what are they called?
The points?
The points. So the 0, 0, the pi over 2, comma 1. Where'd you get those again from? Or is it just like
so
we're supposed to know that?
So this is because we're using sine. So if you went back here, this is where we gave you the key points for sine and cosine.
Right.
So I'm using that list of points because it was a sine function.
Okay. And we're just plugging in.
Plugging them into that map just like we did on the previous one. Yep.
So it's not that bad.
They are, all the problems are very similar, right? They're all basically doing the same skills over and over and over again.
You just gotta make sure that you're factoring properly.
Mm-hmm.
That's basically it.
Yeah, if you can get the right values for A, C, H, and K, it's relatively easy from there. If you can't get those right values, then like lots of mistakes end up carrying through, and you get stuff that doesn't make any sense.
Correct.
But yeah. Okay.
Could you go back to that problem one time?
Yeah, of course. No problem.
Go a little bit to the left. So, is the factor thing the one on the bottom, the y equals the
Yeah. So that was just
factor?
yep.
So you took I didn't do worksheet. I see what you did. Boy,
What did we do? This is what I had asked you. Okay. And then, yeah, okay. Okay. So, did you guys, on the virtual day last week, did you guys look at the lesson from that day?
I did worksheet 1.
Okay. Okay. So there was a lesson from the 6th or the 7th, depending on which day was your virtual day, right? Yeah, it was just like 15 minutes or something, but it was talking about how we do something like, or how we do the problems on worksheet 5.
Okay.
So the idea was just how do we go from like a graph to an equation? Should we run through that?
Sure.
So I'm just going to grab the example problem here. and do that, because this will be part of your homework check.
The video's still on monitor yet.
Yeah, yep, they're all up there. I think everything is pretty well organized by chapter and date and everything. And my summaries are sometimes not the most expansive things in the entire world, but are often going to be good enough. So the idea here is that we want to take this and turn it into an equation. Is that, how clear is that? Is that clear?
What do you mean, like pixel-wise?
Yeah, like can you see the, okay.
Yeah.
Okay. All right. So basically what it comes down to is I want to find the values for A, C, H, and K. And write either a sine equation or a cosine equation from that. Everybody's okay with that idea? That's kind of our goal. Now, for the record, either is always possible. You can always write it as a sine equation or a cosine equation. Okay? And there's infinitely many answers that are correct for these. Our job is just going to be finding one of those infinitely many correct answers. Okay with that plan? So the first thing that I'm going to do is I'm going to identify the midline by just looking at the graph. So remember, the midline divides the graph in half, basically. So the midline looks like here. You guys agree with that? Because there's an equal amount of the graph above the midline and below the midline. What do you guys think, right? So that equation, because it passes through y equals 1, is y equals 1. So that tells me the value for k has to be 1. Because the midline is y equals k. One coefficient down. 3 more to go. Everybody still with me so far? Okay. The next thing I'm going to do is figure out the amplitude. Remember, the amplitude is like the distance from a maximum or minimum back to the midline. So our midline starts at 1, and here it goes up to 4. So that amplitude is 3. Jeremy? Sure. And if we remember, again, the amplitude is the same as the absolute value for A. My stylus has stopped working. Why did that happen? There we go. Okay. Notice that I'm writing this as the absolute value of A is equal to 3. I don't yet know whether that A should be positive or negative. And in fact, there's correct answers where the A is positive, and there's correct answers where the A is negative. We'll sort out which one we actually want to use for the answer we're going to write here a little later. But that's going to be true whether you've used a sine function or a cosine function, that you're going to be choosing from either positive 3 or negative 3 for your value for A. So far, so good? Okay. Next thing we're going to do is we're going to find the period. So the way I like to find the period is by going from like a maximum to another maximum, or go from a minimum to another minimum. So let's say I go from this minimum to this minimum. The period is a horizontal distance. So I started at -1/4 pi and went up to +3/4 pi. So that period must have been 1 pi. Yes, of course. Is everybody okay with that arithmetic? If you start at -1/4 and you end at +3/4, you went 1 full unit. In this case, those units were pi's, but like, who cares about the pi part when I'm doing the arithmetic? And I remember from my equations that a period is 2 pi times the absolute value of c. So if I divide both sides by 2 pi, I get that the absolute value of c is 2. I'm sorry, is 1/2. Everybody okay there? Again, I just solved that equation right there by dividing both sides by 2 pi. So the pi's canceled. I'm left with 1/2. Still doing okay? Now again, notice I wrote here the absolute value of c. The c could be positive or negative. There's correct answers in both cases. What I'm going to do now is I'm going to fix my answer for c to be positive. I'm going to make a choice and say I'm always just going to find the answer where c is positive. Now there are answers where the c is negative, and it would be fine to find one of those. In my experience, it never makes the problem easier to look for an answer where the c is negative. So I'm always just going to, me personally, make the c positive. I would encourage you to do the same. I think it makes the problems a little bit easier that way. Maybe I shouldn't say a little bit. Never makes them harder to do it that way. Is that okay? All right. The last thing we're going to do is we're going to find our value for h. And then, and figure out whether the a should be positive or negative. Okay, this is the trickiest part. So to do this, what I'm going to do is I'm going to map up or pair up a point for my parent function with the same kind of point in my transformation. So my parent function for sine, I'm going to use one of those 5 key points that we use for graphing, and I'm going to match it up with the same kind of point from the transformation that we're looking at. Is everybody okay with that idea? So if I go back and I look at those 5 key points, this point was on the midline, this point was a maximum, this point was on a midline, this point was a maximum, and this point was on the midline. The point that I always want to be able to use, if I have the choice, is this point. If the x-coordinate is 0, finding the h becomes pretty trivial. So if I have the ability to do that, I'm going to try to use that point. Is everybody okay with that idea? Now for my transformed function, I need to pick out also another midline point. So I have lots of choices for ones I could use. All of these are points on my transformed function that lie on the midline. Everybody okay with that? So any of these I can use to get my answer. It doesn't really matter which one I pick. For me, I think I'm going to pick this one because, well, it's the numbers are really easy to deal with. It's the 0.01. Is everybody okay with that? Now, here's the trickiest part for this, now that we've picked our midline point to match up with our parent function, is there's actually two kinds of midline points. So if you go back and we look at the graph of sine real quick. Oops, that's cosine. So notice this midline point, there's a minimum to the left of it and a maximum to the right of it. You guys can see that? If I look at this midline point, here the maximum is to the left, but the minimum is to the right. You guys see that? That the order of the extreme points, the left and right, is different between those two midline points.
Can you say that again?
Yeah, so if I look at this midline point, I have a minimum to the left and a maximum to the right. But if I look at this midline point, here my maximum is on the left and my minimum is on the right. So there's two different kinds of midline points.
That depends where you.
Depending on which midline points you're using.
Oh, okay.
So that's how we're going to determine the sign for A. So my parent function is always minimum, midline point, maximum. So that order is always going to be the same. I'm going to use the down arrow to represent the minimum and the up arrow to represent the maximum. Is everybody okay with that notation? Now I'm going to go look at my graph. So here is my midline point I'm using. The left end is a minimum. The right end is a maximum. Everybody see that? So these are the same kind of midline points. That tells me that my A has to be positive if I'm mapping the same kind of point to the same kind of point. So in this case, my A has to be 3. Is everybody okay so far? The last thing we have to do is find our H. So here's the trick. This is why I wanted to use the point 0, 0, is that if the x coordinate for my parent function is 0, the h is going to be the same as the x coordinate for my transformed function.
So h is 0?
So h is 0.
Is that always the case?
So here's what's going on to let you show you so you can understand why that's the case. So you remember when we graphed these transformations, we used this transformation map, right?
Yeah.
So to get one of these transformed x coordinates, what I did is I did c times the x coordinate from the parent function plus h, right? Now if this is 0, c times 0 is just 0, and it just kind of drops out of there. So we're just left with h is the x coordinate from the transformed function. So as long as our parent function's x coordinate is 0, the h is going to be the same as the x coordinate from the transformed function.
Okay.
That's why I wanted to use the point 0, 0 as opposed to one of the other ones, because it just saves me a little bit of algebra.
So we should, so then like when we do problems like this, we should also use 0, 0.
Yeah, it just makes everything a little bit easier.
Okay.
And my life is hard enough, right? I'm not interested in making my math any harder than it needs to be. Let's do this now for cosine. Okay? Oh, let's write our final answer then. So we have y equals 3 times sine of, the c was 1/2, so 1 over c, x minus h plus k. And again, if you wanted to, you could simplify that stuff down. I'm going to leave it written like this so it's clear what I'm plugging in where. Ashley? Of course. Okay. Let's show you guys what would have happened if we used a cosine now. So we're going to set it up the same way. I'm going to choose a point for my parent function and then a corresponding point for my transformed function. So if I go back here and I look at the key points for cosine, the one I want to use is 0, 1. I want that x-coordinate to be 0 if I have the choice. Now this is a maximum. So when I go and choose my other point from my graph, I need to be looking at things that are other extreme points, either maximums or minimums. Either is okay. So I have lots of choices again. Everybody okay with that? Again, it doesn't matter whether I choose a maximum or a minimum. It'll be fine. For the sake of argument, I'm going to choose this minimum here, which is at negative pi over 4 and negative 2. I'm going to note that that was a minimum because these are opposite. That tells me that the a value had to be negative. And because the x-coordinate here is 0, the x-coordinate in my transform function has to be my h. And I'm done. I got everything I need now. Jay, of course. So just notice when comparing these, the k's are the same. My c's are the same. My a's could be opposite. They don't have to be, but they could be. But my h's are almost always going to be different. In fact, my h's will always be different. Is that okay? Sure.
So for your parent function, when you picked 0, 1, you got that from the thing on the other page. But then for the, is that transverse function?
Transformed.
Transform function. So you just picked any type of...
I picked one of the extreme points from the graph, either a max or a min.
So like if you would have picked a maximum,
then the a value would have been positive.
And then okay. And you just write whatever the x value is.
And the h would have been the x value from that new point that you would have picked.
So basically our h value is always going to be the x point of the transform function.
Yes.
Okay.
For these kind of problems, yes.
Yeah, for these ones.
Go ahead, Leo.
Can you explain how you find the a values again? So like, what else to choose a different point on those like different points?
Sure.
Why not choose 0?
Why did I want to pick 0, 1?
Yeah.
So if you don't pick 0, 1, then the h value isn't the same as the x-coordinate from your transform point. You'd have to write a little equation to actually solve that. That's my motivation for choosing to use that point.
Okay. Will we always have the choice to choose one with the x coordinate of 0?
For a problem where you're taking a graph and turning it into an equation, yes, because you can always read off the graph any point you want, right? Because you have the graph, you have every point on the function, ostensibly, that you can use to do this sort of thing. So you can always use that point because you can always go, okay, I'm going to use this point, and then I'm just going to pick a max or a min from the graph. Because I have those things to use, it's no big deal. Is that okay? Now, if you're given just a description of the graph, and you didn't know a maximum or minimum, then that's a problem. Right? Then you can't use 0, 1 because you don't know any maxes or mins to pair it with. Do you see the difference?
Yeah.
So as long as you know a max or a min, then yes, you can use that point. If you don't know any of them, then, well, is that okay? All right. And then I was gone yesterday. I don't know if anybody, I don't know why you would know that. So what I asked the students in first hour to do yesterday was we started talking about this idea of what I just kind of mentioned to you, Leo, is what if we have, instead of the whole graph that we want to get the equation from, what if I have just a description? So that's what we looked at yesterday. So we'll do a couple of examples of this, or if you prefer, this is already recorded and posted for you guys. We can stop here, let you guys work on these things we've talked about, and you'll watch this video for next time and come with questions regarding this for Friday. That maybe feels like a better idea rather than bombarding you with more. Is everybody cool with that plan?
Yeah, 2 or 2, 3.
Okay, so let's stop.